Today's lesson is on translations. A vector is a directed line segment and looks like a ray. The initial point is the starting point and the terminal point is the ending point. A vector is named from the initial to the terminal point. Our example is vector PQ. The horizontal component, as it's called, is the horizontal distance. The vertical component is the vertical distance. The component form of a vector takes the horizontal and the vertical distance and combines them, so the horizontal form of PQ is 5, 3. It's going to look like the Pythagorean theorem, and that's a way that we could actually find the length of the vector, such as this one. A translation moves every point of a figure the same distance in the same direction. More specifically, a translation maps or moves the points P and Q, for example, of a plane figure along a vector AB to our point P prime, Q prime, so that one of the following is true. Either they are equal and parallel, or they are equal and collinear. One of the things that we learn is a translation is what's called a rigid motion. A rigid motion preserves length and angle measures. The composition of two or more rigid motions is also a rigid motion. So the first thing we're going to do is name the vector and write its component form. This would be vector PQ. Sometimes we use the full arrow. Some books use a half arrow for the vector. It's different from a ray because technically there's a point at the end of a vector, so it gives the direction, and it's called a directed line segment because it's measurable. A ray, remember, is not measurable. The component form, in this case from P to Q, we're going to go horizontal 4 units and vertical 5 units. So our component form would be 4, 5. It's always horizontal and then vertical. In our next example, we're going to take the vertices of a triangle, ABC, and translate the triangle using the vector -1, -2. This means that the horizontal is going to be -1, so -1 to the left, and then -2 is the vertical, so that'll be 2 down. So our vertices are at 0, 3, 2, 4, and 1, 0. If we're going to translate it 1 to the left and 2 units down, we can do that graphically. So move it 1 left, each point 1 left and down 2. We can also look at what the new points would be by subtracting 1 from the x and subtracting 2 from the y. So we're asked to simply translate it, so I would move it 1 to the left and 2 down for each point. Our new triangle is called the image. And so this would be, with what looks like an apostrophe, it's prime for image. This one's asking us in the next example to write a rule for the translation from the original triangle to the image. We always know which one is the image because that one again has what's called the prime, A prime, B prime, C prime. So we're going from, pick a point, we're going from A to A prime. And look at how far we're going to translate it. So we're going to go horizontal first. We're moving 2 to the right. So, and 1 unit down. So my component form would be 2, 1. Another way we can write this is called the coordinate form. So this is component form. We also have what's called coordinate form, which would look the same as what we probably learned in algebra. We're adding 2 to the x, and we'd be adding 1 to the y. In the next example, we're graphing the vertices and its image after the translation. So here's what it would look like. So this one is going to be moved 1 to the left and 4 units up. And here's what it looks like after it's done. So we have the original image, ABCD is graphed, and then its image after the translation, we have it moved 1 unit to the left and 4 units up. So if we focus on a point, A and A prime, it's 1 to the left and 4 units up. Our next example is graphing the endpoint for a segment at -8,5 and -6,8. Graphing the image after the composition, 1 left, 4 up, and then 4 to the right and 6 units down. So here's what it will look like when it's graphed. So again, if we look at the original image and then its second image, we can see that our new coordinates are at -5, 3 and -3, 6. Our last example, in an image editing program, you move the red rectangle 2 left and 3 down. Then you move the red rectangle 1 unit right and 1 up. Rewrite the composition as a single translation. Here are the steps for solving. We're going to focus on the piece right here. The first translation is x minus 2 and y minus 3. The second translation is adding 1 to the x and 1 to the y, so our new answer after the 2 composition of translations would be x minus 1 and y minus 2.